Hi guys, today we're talking about geometric sequences and how to write those equations. A geometric sequence is a sequence where each term after the first term is found by multiplying the previous term by a non-zero number. Okay, this number that we're multiplying each time is called the common ratio. I misspelled ratio. All right, there's common ratio. So we're going to find the next three terms in the geometric sequence. Now remember, this is term 1, term 2. Just like with arithmetic sequences, we number the terms starting with 1, okay? And then we're going to look for the term values here in just a moment, okay? So to find what the next three term values are, we have to figure out what our common ratio is. So to get from 3 to 6, we multiplied by 2. To get from 6 to 12, we multiplied by 2. Okay? The same thing to get from 12 to 24, we multiplied by 2. So to get the next term, we're going to do 24 times 2 and get 48. Then multiply 48 times 2, get 96. We'll multiply 96 times 2, and we'll get 192. Okay? There are two types of equations that we're going to write for sequences. Just like we wrote arithmetic sequences, geometric sequences have an explicit formula and a recursive formula. Okay? Our T sub n is just like our A sub n for arithmetic sequences. This is the term value we want to find. Okay, this is our term to find. And the value. Our R is going to be our common ratio. And I see I've forgotten a couple of arrows here, so we'll have to add in a couple of arrows. The N is our term number. And I forgot an arrow to our T sub 1 because that one's kind of important. That one is our first term. All right, and I promise I will spell first correctly here in just a moment. Let me get that T off. So our first term. Okay, when we look at the recursive formula, the T sub 1 is still our first term. The T sub n is still our term to find. And our T sub n minus 1 is our previous term. If you watched the arithmetic sequence video, instead of using T's, they used A's for arithmetic sequence. And the A sub n minus 1 was the previous term that we were adding the common difference to. So it's the same thing with geometric. It's that previous term that we're going to multiply the common ratio to. Okay, and that R, again, is our common ratio. All right, let's look back at our example that we have up here, the 3, 6, 12, 24. Okay, if we look, 3 is our A sub n, our A sub 1. Okay, the 2 is our common ratio. So if we were to write the explicit formula for it, we would say T sub n equals 2 times, and I made an error. Can y'all spot the error, guys? Instead of putting my first term, I put my common ratio there. My first term is 3. This is what I get for going too fast. My common ratio is 2 to the n minus 1 power. Okay? If I look at my recursive formula, again, my T sub 1 is 3. My T sub n is going to be T sub n minus 1 times 2. So whatever the previous term was, times 2. If I'm looking for the 8th term, I'll take whatever the 7th term is and multiply by 2. Okay, so let's look at some examples on the back. For each of the geometric sequences, we're going to identify the first term and the common ratio. And then we're going to write an explicit and a recursive formula for it. Okay? So if we look at example 1, the 5, that's our T1, that's our term 1. Remember, we want to number these. Okay, 1, 2, 3, 4. So from 5 to 6, we multiply by 5 to 30, we multiply by 6. From 30 to 180, we multiply by 6. And from 180 to 1080, we multiply by 6. So our common ratio is 6. Our explicit formula is T sub n equals 5 times 6 to the n minus 1 power. The recursive formula says that T sub 1 equals 5. And if I want to find a term, T sub n, then is T sub n minus 1, whatever the previous term is to what I'm looking for, times 6. Okay? I want you to try number 1 and pause the video. And when you unpause it, we will make sure you have the correct answer. All right, guys. Thanks for unpausing. And now let's check to see that you did the you try number 1 correctly. So if we look, where did my pen go? Here we go. 1/7 is term 1. 1 is term 2, 3, and 4. To get from 1/7 to 1, we multiplied by 7, then by 7 again, and then by 7 again. So our first term is 1 over 7. Our common ratio is 7. So for our explicit formula, T sub n equals 1 over 7 times 7 to the n minus 1 power. And our recursive is T sub 1 equals 1/7. And T sub n equals T sub n minus 1 times 7. So the previous term times 7. Okay. So you notice on each of these, we're multiplying by a whole number that gets us bigger. Okay. If we look at example 2, our numbers are getting smaller, which means that we're multiplying by a fraction. Okay. So term 1, terms 2, term 3, term 4. To get from 32 to 16, we multiply by 1/2. Okay, we're dividing by 2, which means we're multiplying by 1/2. To get from 16 to 8, we're multiplying by 1/2. To get from 8 to 4, we're multiplying by 1/2. Okay, so our first term is 32. Our common ratio is 1/2. Our explicit formula is T sub n equals 32 times 1/2 to the n minus 1 power. And the recursive formula is T sub n equals, sorry, I forgot T sub 1 equals 32. T sub n is going to be T sub n minus 1 times 1/2. Okay, I want you to try, you try number 2. Pause the video, and after you're done with it, unpause it, and we'll check to make sure you have the right answer. All right, guys, you should have worked out you try number 2. If we number these, 1, term 2, term 3, term 4. You notice that to get from negative 12 to negative 4, we multiplied by a positive 1/3. From negative 4 to negative 4/3, again, a negative 1/3, or positive 1/3, I'm sorry. From negative 4/3 to negative 4/9, again, it's a positive 1/3. Okay, so our t sub 1 is negative 12. Our common ratio is 1/3. Our explicit formula, t sub n, equals negative 12 times 1/3 to the n minus 1 power. And our recursive formula, t sub 1 equals negative 12. T sub n equals t sub n minus 1 times 1/3. Okay. All right, so now we've got some other examples. You'll also see these on your assignment. We're going to identify the common ratio and find the first 4 terms. Okay, now we can use our explicit formula to find any term in a sequence, just like we did with our arithmetic sequences yesterday. So for these next examples, we're going to start a table. And if you have this, then you can also use this to find future terms. Okay? So N1, N is our term number, so let's go ahead and fill this part in. Our ratio. We need to find our ratio. So our ratio is what's being multiplied every time. So that's 3. Okay? This 2 is our first term, our t sub 1. So negative 2. Okay? So there's not a process there. We just needed to look it up. So then the next process is that we're going to do negative 2 times 3 to the 2 minus 1 power. Okay? Or we're just multiplying by 3. Okay? So negative 2 times 3 is negative 6. Okay? We're just multiplying by 3. Negative 2 times 3 to the 3 minus 1 power is negative 18. Again, we're just multiplying by 3. And negative 4, or term 4, is negative 2 times 3 to the 4 minus 1 power. If you're not sure how I'm getting the t sub n values, you can always put this process part in your calculator. Okay? We could put a process in for the first term, even though, it gives us the first term in the equation. The process for this one could be negative 2 times 3 to the 1 minus 1 power. And this is going to give us an exponent of 0. 1 minus 1 is 0. So if you remember back to our exponent rules, anytime your exponent is 0, that base just becomes 1. Okay? So negative 2 times 1 is still going to be negative 2. Okay? I want you to try the you try 3. Pause the video. And then when you come back, we will check to make sure you were correct. Okay, so let's look here. This 1 is our t sub 1. This negative 6 is our common ratio. So we're always numbering. Our n's always start with 1. Okay. So our process, we've got 1 times negative 6 to the 1 minus 1 power, which just gives us 1. 1 times negative 6 to the 2 minus 1 power, okay, gives us negative 6. Since our common ratio is negative, our term values are going to keep flipping signs. They'll go positive, negative, positive, negative. Okay. If our common ratio was positive, then no matter what sign our first term is, it's going to keep that sign all the way through. Okay. So I'm multiplying this by -6, and then I'm going to do that again. Okay. So we're going to get positive 36. 1 times -6 to the 4 minus 1 power. All we're doing is multiplying another -6. We're going to get -216. Okay. Let's look at example 4. If you notice, example 4 is in recursive format. Okay. So the first line gives us our t sub 1. So when we fill in our table 1, 2, 3, 4 for our n, it tells us our t sub 1 is 6. Okay. So there's not another formula we're using. We're just doing t sub 1 equals 6. Our common ratio is just 1/3. Okay. So we're going to do 6 times 1/3. We will get 2. We'll do 2 times 1/3 and get 2/3. When we do 2/3 times 1/3, we get 2/9. Okay. You try number 4. Pause the video, and when you unpause it, we will check to make sure you're right. All right. So you should have unpaused it, and let's check to make sure you did this right. So here's your t sub 1. That is your first term. Okay. It tells us that t sub 1 equals 16. This 1/4 is your common ratio. So we're going to do 16 times 1/4. We're going to get 4. 4 times 1/4. We're going to get 1. And then 1 times 1/4. We will get 1/4. All right, guys, that's the end of your notes for geometric sequences. If you have questions, you can text me through my Remind. And you have your assignment where you are writing geometric sequences and finding different terms within those sequences. I will see y'all later, and have a good weekend. Bye.